Ever wondered how business or researchers estimate a specific problem in a population or a community? Well, there is a simple equation behind it. First of all, we need to know the basic concept of sampling distribution. A sampling distribution is a probability distribution of a statistic obtained through a larger number of samples drawn from a specific population. The sampling distribution of a given population is the distribution of the frequencies of a range of different outcomes that could possibly occur for a statistic of a population. For example, suppose you wanted to find out the sampling distribution of statistics scores for all senior high school students in a given year. To do so, you would take repeated random samples of senior high school students from the general population and then compute the average test score for each sample. The distribution of those sample means would provide you with a sampling distribution for each average statistics score. Sampling is a term used in statistics that describes the methods of selecting a predefined representative number of data from a larger data population. There are many different sampling methods, but whatever the sampling methods, the sample should always be representative of the larger data pool from which it is taken. Random sampling. A simple random sample is a subset of statistical population in which each member of subset has an equal probability of being chosen. An example of this is when a respondent have their names represented by a small folder of paper which are mixed together and picked out at random. Random sampling is a probability sampling method and a form of random sampling in which the population is divided into two or more groups, according to one or more common attributes. A standardized sample is constructed by classifying the population in subpopulations or strata based on some well-known characteristic of the population such as age, gender, social, economic status.
Suppose that you were a researcher interested in studying the income of American college graduates 1 year after graduation. The population that you are interested in is American college graduates. You find out that each year there are over 1,750,000 people graduating from college. It's impossible for your research team to collect data from every member of your population, so you decide to collect data from a sample. You and your research team decide that you want to take a sample of 3,000 American college graduates. Assume you chose a random sample of 3,000 college grads. You look at the demographics of your sample participants and find that 2,034 are Caucasian, 832 are African American, and 134 are Asian American. You start to wonder if there are any differences in income 1 year after graduation between the different racial subgroups. You also wonder if the demographics of your sample are truly representative of the demographics of American college graduates. One way of examining these questions is by using a stratified random sample. Suppose that instead of conducting a random sample, you look up the demographics of American college graduates
and find that 51% of American college graduates are Caucasian, 22% are African American, 9% are Asian, 8% are Native American, 5% are Hispanic, 3% are Pacific Islander, and 2% are multiracial.
You divide your population into strata based off the participants' racial demographics. Here you have 7 strata, 1 for each of the 7 racial categories. Using this information, you can conduct either a proportional stratified sample or a disproportional stratified sample. Let's assume that you have decided to conduct a proportional stratified sample. Your next step is to ensure that the proportion of the strata in the population is the same as the proportion in the sample. This means that 51% of your sample needs to be Caucasian, since 51% of the population is Caucasian, 22% should be African American, 9% Asian, 8% Native American, 5% Hispanic, 3% Pacific Islander, and 2% multiracial. By calculating the proportions, you determine that the racial demographics of your 3,000 study participants should include
3,000 times 0.51 equals 1,530 Caucasians, 3,000 times 0.22 equals 660 African Americans, 3,000 times 0.09 equals 270 Asians, 3,000 times 0.08 equals 240 Native Americans, 3,000 times 0.05 equals 150 Hispanics, 3,000 times 0.03 equals 90 Pacific Islanders, 3,000 times 0.02 equals 60 multiracial.
You can see that the demographics of the stratified random sample are very different than those of the random sample. Now that we have our population broken into strata and we have identified how many study participants we need from each strata, the next step is to use random sampling in order to pick the specified number of participants from each of the 7 strata. In other words, we randomly select 1,530 Caucasians from all of the Caucasians in the population. We randomly select 660 African Americans from all of the African Americans in the population, and so forth. Once we have chosen our study participants from each stratum, what we have is a stratified random sample.
Systematic sample is a type of probability sampling method in which sample members from a larger population are selected according to a random starting point and fixed periodic interval. This interval, called the sampling interval, is calculated by dividing the population size by the desired sample size. For example, if the population size is 10,000 and you wanted a sample of 1,000, you would select every 10th element for your sample. The main advantage of using systematic sampling is its simplicity.
For example, restaurant surveys. Another survey that uses sampling and allows subjects to select is restaurant surveys. Often, a customer's bill that asks them to fill out information about the food service and their visit and gathers information about their performance from the customers who choose to respond to the survey. These surveys sometimes encourage customers with coupons or special deals for their next visit upon completion.
Learn something from our short discussion. Thank you and have a great day.